All right, first we're starting off with just some antiderivatives that you guys need to know. The antiderivative of sine, we know it's going to be cosine, it's just whether it's positive or negative. So think about the derivative of cosine is negative sine, so the antiderivative of sine needs to be negative cosine. Antiderivative of cosine is just sine because the derivative of sine is just cosine. I haven't memorized any new antiderivatives, I just know my derivative rules and then you go the opposite. Antiderivative of secant squared, so the thing that the derivative of it is secant squared is just tangent because derivative of tangent is secant squared. And derivative of secant is secant tangent, so the antiderivative of secant tangent is just secant. Antiderivative of e to the u is just e to the u, that is the easy one, just stays the same whether you take derivative or antiderivative. And antiderivative of 1 over u is just natural log of u. For g, we need to rewrite this, so this is just the antiderivative of u to the negative 2. And then to take the antiderivative of u to some power, so that's what we have right here, we're going to add 1 to the power, so that would be u to the negative 1, and divide by that power. So we're going to add 1 and then divide by that number, so this is just negative 1 over u, because negative 1 is the coefficient, and then u to the negative 1 means put it on the bottom, plus c. Here we write, this is u to the 1/2, antiderivative you're going to add 1, so 1/2 plus 1 becomes 3 halves. And I need to divide by this power right here, so I'm going to divide by 3 halves is the same as multiplying by the flip, so 2/3 plus c. Antiderivative of u to the 4th, this is just power rule, because I have u to some power, u to the 5th over 5 plus c, add 1, divide by that number. This, right, we would not be able to use u substitution because, yes, you have a u squared, I've got this inside function, but I don't have a u that will cancel out my du. So these, right, you just need to recognize them. This is what we talked about in class this week. This right here is literally arc tangent plus c, and this right here is just the arc sine. The same way, we just know the antiderivative of 1 over u is natural log. We should just know, oh, the antiderivative of this, that's just arc sine. This is just arc, this is arc tangent. This is arc sine. All right, finding the average value of f on the interval a to b. So this is just a formula you need to know. The average value is 1 over b minus a, integral from a to b of f. To find antiderivative, so this is a definite integral, right? I have to evaluate it. So the antiderivative of f prime is just f, and then I need to evaluate it at b and a, so that would be at b minus evaluated at a. That's our first fundamental theorem. Now our second fundamental theorem is the derivative of the integral of f from h to g. So I'm going to make a note that you only use this if you are taking the derivative of an integral. So that could be that f is the antiderivative of g and you're looking for f prime, right? Or that could be you're doing d dx of some integral, blah, 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 something like this. That's how you know whether to use the second fundamental theorem or not. And what the second fundamental theorem does is we have derivative and we have the integral. Derivative and antiderivative basically cancel out, so I'm just left with the same function f of t, except it's not t anymore because I have to substitute these in. So this will be f of g of x, and then minus evaluated at h of x, so f of h of x. All I've done is kept the exact same function, because derivative and antiderivative just cancel out and keep the exact same function, but I have to evaluate it at g and at h, because these are like my a and b, and I need to multiply by derivative of what I plugged in, so that would be times g prime and times h prime. Now the reason I'm not doing that here is because I'm not taking the derivative of this, so I had to actually find the antiderivative of f prime, which is just f, and then I evaluated it b and a, nothing about derivative here. Here I'm taking the derivative of the integral, so this is going to kind of cancel each other out. I just am left with f, and I have to plug in, just like before, but because I took the derivative, I have to take derivative of what I plugged in. Alright, rate at which oil is leaking out is modeled by this function, so this is the rate out. It's in liters per hour. How much oil leaks out during the first half hour? So this is the rate out. To get the amount out, I would do the antiderivative of the rate. And I want it in the first half hour, so that would be 0 to 0.5 or 1/2 hours. And then we have a calculator, so we'll just use our calculator because I do not know how to take that antiderivative. Make sure mode is radians. And then integral, we'll just do math 9. And we're going from 0 to 0.5 or 1/2, same thing. And then this is 2 plus sine of 3x squared. And with respect to x, and that is your integral. You get 1.12. So then C. And there was no initial value, and even if there was, I wouldn't need it because I just want the amount that leaks out, not the amount that there is or left over, etc. All right, C, G, or 2, whatever. 2, G is the function defined. G is the antiderivative from 0 to x of f of t. Where is G decreasing? Where is G concave up? So let's start with A. G decreasing, you should automatically go, oh, G prime is negative. We know that. Now let's think about, I have a graph of F, so I want to know what is what is G prime in terms of like F? Is it the area, is it the slope, etc.? So let's look. G is the antiderivative. So when I take the derivative of this, oh, that's taking derivative of an integral. This will just cancel out when I take derivative and just become f of x. So g prime is just f of x. So if I want where g is decreasing, that's where g prime is negative. I have a graph of f, and f is just my g prime. So this is also just a graph of g prime. So if I want where g prime is negative, that's in here. So from 2 to 4. Right, asking where G is concave up, so concavity, again, we know about G prime, so concave up is G prime is going to be increasing, and G prime is increasing in this right here, because this is a graph of F, which is just G prime, and it's increasing from -3 to 0. Now, if you're like, how did you know concave up was this? Remember, we have our like little table we can do. So this is F prime, this is F double prime. Okay, that way we go through. If this is increasing, your derivative is positive. If this is decreasing, your derivative is negative. If this is concave up or concave down, that means F double prime is positive or negative, and that means that F prime is increasing or decreasing. So this is the same relationship, just shifted over. So that can be helpful if you forget your rules. C, the derivative of f is continuous. If this is true, then what is f of 6? So let's think about the antiderivative from 3 to 6 of f prime will just be the antiderivative of f prime, which is f at 6 minus f at 3. I'm looking for f at 6. F at 3, I can just go to the table, it's 2. And then antiderivative from 3 to 6 of f prime, it just gave me that right here. See how that's equal to 5? And then I just add the 2 over to get f of 6 by itself. So f of 6 must equal 7. The temperature in degrees Fahrenheit of a cake is given by this. This is the temperature. To the nearest degree, what is the average temperature in the first 8 minutes? So this looks a lot like what is the average value of that function from 0 to 8 minutes. So I'm going to do my 1 over b minus a. So this will be from 0 to 8. Integral of the temperature, so 74 plus 92 e to the negative 0.062 t. And then I go from 0 to 8, and now we just literally type it in the way it is. We've got 1 over 8, math 9, 0 to 8, 74 plus 92, e to the negative 0.062x, 146.53, which is 147. And just be really, really careful, because if you forget to do the 1 over 8, you get D. So if you got that, it's because you forgot to put the 1 over 8. You just found the area, which is not the average value. You have to do the 1 over b minus a. All right. U substitution, it tells me this is my U, and which of the following is equal, so you'll notice that this is still in the integral form, so I don't actually have to find antiderivative, I'm really just rewriting it. So this is h of u. Now I need to replace dx, so let's find du. That would be negative 4 dx. Divide the negative 4 over, so this is du over negative 4. And then I cannot write negative 1, negative 3 because they're not still negative 1 and negative 3. That was in terms of x, now everything's in terms of u, so I have to find the u version of this, so just find what's u of negative 3. So you plug in. This is 2 minus 4 times negative 3, because I'm plugging into u. That's 2 plus 12, which is 14. So the negative 3 just becomes 14. And you have to make sure it goes in the right place, because sometimes people just put the smaller one on bottom, and that's not true. The negative 3 became 14, so that's where it goes. And then u of negative 1 is just 2 minus 4 times negative 1, which is 2 plus 4, which is 6, so that goes right here. So this is, all I've done is replace everything in terms of u. This is u, dx became du over negative 4, and then these I plug into u to get the new values. Now this is negative 1/4 integral from 14 to 6 h of u du, and then none of my answer choices look like that, so let's think, well, this one is just flipped, 6 to 14. It's totally fine to flip it as long as you flip the sign, so see how that becomes positive 1/4 h of u du, then your answer is A. 6, a particle moves so that this is the acceleration. The velocity at 0 is 10. What is the velocity at 4? So let's think about, I have acceleration and I want to get to the velocity. Well, acceleration is the rate of the velocity. This is the derivative of velocity. So to get back to velocity, I do antiderivative. So I'm going to be doing the antiderivative of the acceleration. I'm going from 0 to 4. And what this gives me is not the velocity at 4, right? It gives me the velocity at 4 minus the velocity at 0. Again, you can think of the acceleration as just v prime, right? Derivative of velocity. So this is like v prime, so the antiderivative would just be v. And then we go to our calculator because you do not want to take that antiderivative. So this is math 9 from 0 to 4 of parentheses x plus 2 over the square root of x cubed plus 4, like this. You have to have parentheses over that x plus 2, otherwise you're doing x plus 2 over all of that, which is different. So that is 4.311 is v of 4, what I'm looking for, minus v of 0, which is 10. Then all you have to do is add the 10 over. It says that f is the antiderivative of this. So let's think, if I'm doing antiderivative of this, that's integral of that. That's going to give me f. And if I go from, what is it, 1 to 4, then that will give me f of 4 minus f of 1. And now I just do this in my calculator. Math 9, 1 to 4, x squared divided by 1 x to the 5th. Make sure you have your parenthesis around the bottom. X. So that is 0.3756. F of 4 is what I'm looking for. F of 1 was just 0, so then adding 0 ever doesn't affect it, so it's just D. Now 8 is different because it says this is the antiderivative of f. So if I'm finding antiderivative of f, that's just going to give me x squared over 1 plus x to the 5th. So if I do the antiderivative from 1 to 4, well, I'm just going to be doing this from 1 to 4. But I don't need to do the antiderivative or the integral in my calculator because I've already been given what the antiderivative of f is. So all I have to do is plug in at 4 minus plugged in at 1. So this is just the x, or I guess 4 squared over 1 plus 4 to the 5th minus 1 squared over 1 plus 1 to the 5th. I'm just plugging in at 4, subtracted by plugging in at 1. You can type it out, or most of you, just to save time, probably said this is x squared over parenthesis 1 plus x to the 5th. And then you just evaluate, so y1 of 4 minus y1 at 1. So then this gives me negative 4.484. That's your answer, B. So if you're wondering how are 7 and 8 different, so what's different here is I gave you, I did not give you the antiderivative. I said, hey, the antiderivative of this is f, so find what the missing f is. Whereas here I said, oh, the antiderivative of f is this. If you want the integral from 1 to 4, you already have the antiderivative. You just evaluated at 4, subtracted by evaluated at 1. 9, so just looking at your answer choices, that definitely looks like u substitution. But I also would know u substitution just because you have an inside function inside of your other function. So if u is 3x, du is going to be 3 dx. Divide the 3 over. Rewrite this. So this is the integral of f of u, du over 3. And then this is still equaling 5. I haven't changed anything about equals 5. Now I have changed these bounds. It is not still 1 and 4 because it's in terms of u. So find u of 1, find u of 4. U of means you plug into u, so 3 times 1 is 3. And then plug in 4, that becomes 12. So this is, the 1 became 3 and the 4 became 12. So then this, all I've done is rewrite it in terms of u. And looks like the question is trying to get the integral by itself. So I'm going to just say this is a 1/3. So if I want to get this by itself, to get rid of the 1/3, you just multiply the 3. So multiply both sides by 3. That cancels out, and now I have 3 to 12 f of u du is equal to 15. Here I want the average value. So average value tells me 1 over b minus a, integral from, a to b, f of x. This is just 1 over 9. The integral from -5 to 4 of f would just be the area from -5 to 4. So we've got 2 times 2 over 2, so this is 2. This triangle is 1, 2, 3, 4, 5 times 1, 2, 3, 4 over 2. 5 times 4 over 2 is just 10. And then here we've got 1, 2, and down -4. 2 times -4 over 2 is -4 right here. So we've got positive area of 12 minus area of 4. So that gives me an area of 8. So this integral right here is just 8. So average value would be 1/9 of that, so 8/9. A cup of tea is cooling in a room that has a constant temperature of 70. If the initial temperature of the tea at t equals 0 is 200, so that seems important. And the temperature changes at this rate, so this is the rate of the temperature. What is the temperature after 4 minutes? So I'm going to do the antiderivative of the rate in order to get back out the temperature, right? Antiderivative of the rate and temperature will just give me temperature. And I'm going to go from 0 to 4 to get me t of 4 minus t of 0. And then we just do this in our calculator. Math 9, 0 to 4, oops, 0 to 4. Negative 6.89. Now that is not my answer, right? Because that's just the amount that the temperature has changed. I want to know what the t is at 4 minutes, and t of 0 was the 200, so you just add the 200 over, and that gives me 175. Most of you probably just are used to initial values, so you might have just said, oh, this is 200 plus the amount change. That's totally fine. That's what you're doing here, just whatever way you think of it. At 12, this is the typo that should have been a negative right there. I have f prime and I want f, so I definitely am doing antiderivative, right? Antiderivative of f prime will give me out f, and I want to know at 1 and I know at 4, so I'm going to go from 1 to 4. And that will give me the antiderivative of f prime, which is just f at 4 minus at 1. F of 4 is 3. F of 1 is what I'm looking for. And then I just put this one in my calculator. Math 9. 1, 2, oops. Okay. And this was e to the negative x squared. That gives me 0.193. 0.139. I'm going to subtract the 3 over. That gives me negative 2.86 equals negative f of 1. So then I just divide the negative out. So then it is 2.860 is your f of 1. Alright, no calculator, throw calculator away. I want the integral. A lot of people in class went straight to b, because like, oh, I know this, you just put the x in.